In this video, we are going to learn how to calculate monthly loan payment using compound interest tables. So I have a simple problem here. Let's first read the problem, try to understand the problem statement, try to understand what we want to find out, what inputs are given, and then we will work on the solution. So let's read the problem. Suppose you wanted to buy a $180,000 house. You have $20,000 cash to use as the down payment. The bank offers to lend you the remainder at 6% nominal interest. The term of the loan is 20 years. Compute your monthly loan payment. So, very interesting. We are talking about a mortgage payment. The house cost is $180,000, but you are going to make a down payment of $20,000. The loan the bank is offering you has 6% annual interest, and you have to pay it back in 20 years. So you want to calculate what will be your monthly loan payments. So simple problem. First, let's write down what is given to us, and then we will discuss the solution. So first thing that is given to us is letter P, which is the present value of loan in this case, right? That is how much loan you are taking, what is its present value. So that is $180,000 minus, because you are out of that $180,000, $20,000 you are paying upfront. So that should not be in your loan calculations. So you need to subtract $20,000 from the house price. So minus $20,000 is equal to $160,000. So that's one number. It's a p value. It's the present value of the loan is $160,000. Okay. Next thing that is given to you is uh, the n, which is basically how many pay periods, how many pay periods are there in the problem, or how many payments you are going to make. So you are going to pay back this loan in 20 years, and every year you are going to make 12 payments, because we want to calculate monthly. This is important, right? This monthly loan payments, so I'm just underline that. That's important. Sometimes it can be quarterly, it can be weekly. So depending on that, if it was quarterly, then you have to take 20 years and multiply by 4. That would be 100 payments, right? If it is bi-weekly, then you have to multiply it by 24. uh, but now we want, in this case we want to calculate monthly loan payment. That's why I am multiplying 20 years by 12. So that would be 240 months. Once again, as I said, your n periods can be years, can be quarters, can be months, can be weeks, depending on the context of the problem. Okay, and we want to remain consistent. If one thing is given in months, all other things should also be given in months, right? We should we should not have one term that is in terms of months and other term that is given in terms of years. That will lead to miscalculations. Okay, so P and N we know. What else do we know? We know the interest rate, right? So that is I. I represents interest rate. That is 6%. But here we have to be careful, because, as I said just now, that if one thing is in a month, we have to be consistent. And this is 6% nominal interest rate. This is given as an annual interest rate, and we are calculating monthly loan payment. So that's not matching. We have interest rate annually, and we want to calculate monthly loan payments, and the number of pay periods are also given in. Now we converted them in months. So we also need to convert our interest rate in months. So that would be 6 divided by 12. We take annual interest rate and divide it by 12. So that's going to give us 0.5% per month. Okay, so everything is consistent now. Okay, so now we know the inputs, and what do we need to calculate? We need to calculate A. Basically, A refers to equivalent uniform annual payments or monthly payments or periodic payments, right? uh, when you pay equal amount every month or every quarter or every year, equal value, right? Equal payments, so that becomes A. That is uniform, uh, equal, right? It can be annual, monthly, weekly, as I said, but consistent loan payments. So that is given by letter A. So now we want to calculate A. So let's work on that. I think I already have all of these calculations, so I'm not going to repeat that. So here we are. uh, I already have the formula. uh, I want to, maybe write down a simple formula that you understand, and then plug in the values. So A is equal to, okay, we know what is given to us is P. So we take that and multiply that by A given P factor. And this we can find in the compound interest tables. A given P factor, uh, P is given, and we want to calculate A. So that's the A given P factor at some interest rate and n comma n number of payment periods. So that's the simple formula when while using the compound interest tables. And this formula remains same for calculating different things. Only the factor changes, and this is true about all compound interest table applications, right? So if you have given A and you want to calculate P, then P goes here, A goes in the right hand side, and the factor becomes uh, P given A, because now A is given and you want to calculate P, so you need to multiply that A by P given A factor. If you want to calculate future value and present value is given, then that would be F given P. So this factor can change depending on what is given and what you want to calculate. And then everything comes at a certain interest rate and what are the number of payment periods. Okay, so let's plug in the values. A is equal to, value of P is $160,000, times the factor A given P at 0.5%. uh, I already have the answer here, but let's see how I got to the answer. I is 0.5%, which we already calculated, and n is the number of payments or number of pay periods, which is 240. Okay, so now we want to find this factor, right? So I'm going to go to the compound interest tables. You can Google them and search them upon Google. I have it here already. We need to look at 0.5% compound interest table. So this is one fourth, 0.25%. That's not going to work. We want to find out half a percent, one half. So here it is. This is the compound interest table that we are interested in, half percent. Okay, and there are lots of different factors are given in the column captions: F given P, P given F, so on and so forth, depending on what is given and what you want to calculate. So we want to find out A given P. So that is under uniform payment series, right? A given P, this one. This column is we are interested in. Okay, so we need to look at this column, but what row number should I look at? So you will see here on the very first column, uh, N is the number of pay periods or number of uh, periods, right? In our case, we are doing monthly calculations in terms of months, and N is equal to 240 months. It doesn't matter for the table. If our problem is in years, you can consider these as years. If our problem is in months, you can consider these as months. So you are going to use the same tables, right? But what n is it, what unit of n is, it doesn't matter when looking in the table, right? So 240 months, so I should be looking at, hopefully we have that number. So here we have 240 months, and p given, the a given p is the fourth column, right? So let's take a look. Fourth column, so this is the number 0.00716. That is the factor a given p. So let me write down that. So a is equal to 160,000 times, once again, what is the factor? 0.00716. 0.00716. Now before we do this calculation, I want to um, make a comment on this, about this table. We were lucky in this case because we found the exact n number that we were looking for. But many times we may not find exact n number. For example, what if n is equal to 300? So we don't have that here, right? We have 240 and we have 360. We don't have a number 300. Then what should we do in such a case? So then you should then look at a row before, a row that has number smaller than the number that you have, and a row that has a number that is higher than the n value you have. So 240 and 360. So you can look at the a given p factor for 240, which is 0.00716, and for 360 it is 0.006. So because your number is between these two numbers, your a given p value should be between 0.00716 and 0.006. It cannot be bigger than 0.0716, or it cannot be smaller than 0.006, because that will not fit in the limits. So within these limits, but where exactly it would be, right? So for that you can use, as you know, the process of interpolation, in mathematics, linear interpolation, to find out the value that is between the two values, right? I'm not going to explain that in this video, but if you just Google search process of interpolation, you should be able to understand that. Or maybe I will make another video that will explain how to do the interpolation, linear interpolation. But anyway, this in this our problem, it was easy, 0.00716. So I have it that here, and then you can do the multiplication. $160,000 times a given p, which is 0.00716, and that is $145.6 per month. So that's our final answer. 100 uh, 100 $1,145.60. So that's the monthly payment you will have to make for 20 years to pay back your loan completely. So that's where I will stop. Thank you.